All right, I want to welcome back Hononegah Honors, Algebra 2. Section 4.4, we're going to dive more into factoring, except we're going to be factoring things that are not just quadratic. So we're going to upgrade our degree. It doesn't change how we factor something, but always check for a GCF first. So again, if that should always be your first part of factoring. So if I want to factor something, I should always look to see if there is a greatest common factor. So in this first one, x cubed plus 10x squared plus 24x, I see that I can take an x out of all of them. So again, that is your first go-to move. And then the parenthesis factors again. So there's factors of 24 that add up to 10. And so 6 and 4. And so then therefore this factors completely. And again, don't forget also about the fact that you did have a GCF. That GCF still needs to be there in your answer. So just because you are taking out something in the beginning, like 5y to the fourth is the GCF on the next one, and you're left with y squared minus 25, that GCF still is in my answer, even though I factor again. And so this is difference of squares, and so y minus 5, and then y plus 5. So again, don't forget the GCF when out in front, and then look to factor again. That's going to be the whole factor completely part that will be on your test and be on your quiz. So again, I'm looking at a GCF of 6. And then it factors again because factors of 2. Now, I'll accept that answer. You could also write it as z minus 2 squared. So either one of those answers would technically be correct because you end up having the same parenthesis twice. This is new. This will be a factoring that you guys have never done before, and so we really need to go through this. This is a memorization of the pattern. So I can actually factor if I have two cubics, okay, two perfect cubes, a cubed plus b cubed, and I actually can factor if I have two cubics that's subtraction as well. So it's different than difference of squares. Difference of squares is always a minus sign. Cubics can actually be done either plus or minus. Now, with that being said, I want to go through the pattern here. Even though it's going to be written right there, I want to talk about it. Every time we factor cubics, okay, a cubed minus b cubed. Here's how the pattern goes. Whatever it is without the cube is your first parentheses. You'll notice in the top one it's a plus b, and in the bottom one it's a minus b. So whatever the first parenthesis would be is the same as what it would be without the cube. Next, you're going to take the first term here in the parenthesis, and you're going to square that. Then you're going to take the two of these, multiply them together, but change the sign. Okay, so this is the opposite sign. And then multiply the two together. And then the last one is always a plus sign, and then it's the second one squared. So that pattern is the case. So I'm going to go up here to the top so you can see it again. First one squared, multiply the two together and change the sign. Last one squared. And you don't need the arrows. I'm just trying to show you how this pattern actually works. So let's try one of those. Rewrite the question as 2 perfect cube. That would be my first suggestion to all of you. So x cubed minus 4 cubed. First parenthesis is just the way it looks without anything else. Then take the first term and square it, change the sign and multiply, and always add the second one squared. Now, the next one, really you should look to see if there's a GCF first. Remember, that is always the first item that I look for. So I can take something out of this. And if there's ever a negative in front, I really should take a negative out as well. So I'm going to take out a negative 2x squared. And what's left is 8x cubed minus 125. Now, forget about the GCF. It's going to stay there in my answer. Let's talk about what's in the parenthesis. This is technically 2 cubed, x cubed, minus 5 cubed, which meets my criteria. That is a perfect cube in the front and a perfect cube in the back. So I have 2x minus 5. Now, the pattern is take the first term, square it. So notice that I squared both the 2 and the x. Change the sign and multiply the two terms together, and always add the second one squared. This would be factoring completely, so breaking this down into its factors. Some polynomials you can factor by grouping. Okay, so if I have 4 or more terms, I can also look for grouping. I could take an x squared out of the first 2. I can take a -9 out of the second 2. And then I can group what's in front. Now, this gets us to another topic. Sometimes when you factor, you will end up with something that is factorable again. So x minus 3 and x plus 3, because that's the difference of two perfect squares. X squared is a perfect square, 9 is a perfect square, and so I can factor that again because it's the difference of perfect squares. So sometimes when you have 4 terms, you should ultimately look for factor by grouping. Factor each polynomial completely. So I see this as being something that I'm looking for. Sorry, I'm being interrupted here by a bell. All right, so 625. Now, 625 is a perfect square. It's actually 25 x to the 4th. So that is a perfect square, 25 x to the 4th. 256 is a perfect square. It's 16 times 16. Now that I factored by difference of squares, I look to see if I can factor again, and that is another factor. Now, x to the 4th, 25x to the 4th plus 16 you cannot do. It has to be the difference of squares. It has to be a minus sign. So this would be 5x squared minus 4 and 5x squared plus 4. Why I wrote a 2, we don't know. So again, difference of squares. Now, 4 is a perfect square, but 5 is not. So that is as far as I can go on factoring completely. Notice the next one. Quite large. There is a GCF. 2x to the 5th can be taken out of all of them. So I'm going to divide each of them or take out like x to the 8th minus 5x to the 4th plus 4. Forget about the fact that it's x to the 8th. Think about this as being a trinomial. Anytime the middle term is half of the first term. So normally I would have x squared minus 5x plus 4. And notice that the middle term is half of the first term. I can still factor this in the same way that I factored previously. It's just instead of having an x and an x, I'll have an x to the 4th and an x to the 4th. Now, x to the 4th minus 4 and x to the 4th minus 1 would be two factors of 4 that would add up to -5. This factors again. This is a great question, by the way, and I do ask one, I think, similar to this on the test. 2x to the 5th, the first one is two perfect squares again. X squared minus 2, x squared minus 2, and x squared plus 2. The next one, x squared minus 1 and x squared plus 1. And hold on a second, there is one more that is a difference of perfect squares. I'm trying to move this out of the way and it's not letting me. There it goes. So now there's one more. So our final answer, 2x to the 5th. I have an x squared minus 2 that is not perfect squares. I have an x squared plus 2 that again is not perfect squares. I have an x squared minus 1, which is, it's x minus 1 and x plus 1. And then I have a last one of x squared plus 1. Sorry, I didn't have the squared in there. And that is factored completely. So we are factoring this down to the smallest factors that we can possibly make. Your homework assignment is out of the book. Notice on 73, I'm only asking you to do part A and B. If you have any questions, please make sure that you talk to your teacher, and good luck.